Hey everyone, we are going to begin 11.3 today. So we're going to start with a warm-up because we are going to talk about our measures of center, mean and median specifically. But what I want you to do is review how to find the mean, median, and mode of this data set that you see here. So go ahead, pause the screen, find those different measures of center, and then play it and you can see my answers. Here I've calculated the mean, so adding up all of the different temperatures, and there are 10 total, so dividing by 10 you get about 79.9 degrees, and you can see that they had the average high already listed here. Listed out my temperatures from least to greatest, found the middle value, which was going to be 75, and then our mode is also 75 because that occurs the most often. Now, the question says, which of these do you think seems to be the most accurate in describing the data? Now, the thing with statistics is a lot of times everything is up for interpretation. So this can kind of vary depending on how you think of the problem. What do you think most accurate really means? The mode, just because 3 days were 75, I don't know if that necessarily would be the most accurate. The median is looking at that middle value. Now, it would be accurate for the first 7 or so days. I would think that 75 would be pretty accurate. But notice it doesn't really show that you had 3 really nice days of 90 and 95 degrees. The mean, you can see that does incorporate your higher temperatures a little bit better, and it puts the average up to about 80. So again, it's kind of up for your own interpretation for what you consider to be the most accurate. In 11.3, we're going to be using our mean and median to talk about interpreting different shapes of data displays. And today specifically, we're going to look at symmetric, right-skewed, and left-skewed data. So here's our essential question for the day. And then this will go into 11.3b as well, interpreting shapes of data displays using different types of data distribution. And remember, those were our histograms, our dot plots, and our box plots. In this example, we see 2 histograms that show the weights of all dogs that were entered into 2 different categories in a dog show. Looking at each set, what inferences can you make based on the shape of the data? So before we actually look at specific numbers, right away, what do you notice about the shape of each histogram? Do they look the same to you? What kind of things can you observe about them? One thing that I see is this first one. If you kind of look at the general shape, it kind of looks like it might be pretty evenly distributed. Whereas this one, you can see that you have a lot of the values, a lot of the weights are more so over on that left end right there, kind of the lower weight dogs. On this slide, we can see that they give us the mean and the median. So I had drawn kind of this bell-shaped curve here, and you can see that they tell you the mean and the median are both 45. So in this case, on the left, your mean is equal to your median. Now, in this case, we call this a symmetric distribution, or your data is symmetrical data. So here we have symmetric distribution. Your mean is equal to the median, and you can see that these data points are pretty evenly distributed on both sides. So what can you infer about the dogs in this case, or their weights? I would say that you can say their weights are probably between 10 and about 49. And that's because you have that kind of central tendency there where most of the values are kind of in the middle. On the right here, now we call this, you can see my curve starts higher and kind of tapers off at the end. In this case, you can see that your mean is bigger than your median. So they tell you that you have a mean of 27 here and a median of 24. So your mean is bigger than the median. In this case, we don't call this symmetric, but this is what we call right skewed, or skewed right. And this will always happen when the mean is bigger than the median. Even though it looks like a majority of these values are on the left here, when we have something that's right skewed, think of the tail being on the right. So what I mean by the tail is kind of where it flattens out here. We call this that tail. So when that's on the right, we have it right skewed. And you can think of that tail as kind of pulling the mean. So the mean is bigger than that median. Now, when we're estimating or trying to make conclusions here, you can see that a lot of your values are kind of here before 30. So if I were to make an inference about this, I would probably say that the weight of these dogs are less than 30. So let's look at another example of a skewed histogram. Here it says customers of a bagel shop complain that some bagels weigh less than the amount on the label. Quality control manager randomly sampled 30 bagels and weighed them. Based on this sample, is a change in the process of making bagels warranted? So if we look here, now you can see that this data, here's our little tail, kind of starts off, and then we have that curve going up. So this would be a case where we have left skewed data. So I have my tail is on the left here. That's why it's left skewed. And in this case, if you look at your mean and median, the mean is now smaller than your median. That will always be true when your data is skewed to the left. And in terms of answering this question, based on the sample, now notice he only weighed 30 bagels, so that sample size isn't that big. But based off of this data, yes, you do have the mean weight, the average weight being less than what it does advertise on the bag here. But it is pretty small and your sample size is pretty small. So he could, because the mean or the average weight is less than what they advertise, he could make a change in the process. But that's really up to him, or he could always take another sample, which is what we're going to look at tomorrow. So in general, the mean is smaller than advertised, but he should take another sample. So to kind of summarize, looking at histograms specifically, how does skewed data affect the mean? So these are the 3 histograms we've seen so far. The one on the left, you can see this would be, for the most part, symmetrical. And like we said, the mean is equal to or really close to the median. Here, when it's skewed to the right, because my tail is on the right, you can see that my mean gets bigger. It increases, that tail pulls that mean to be bigger, so the mean increases and is bigger than the median. And then when we have something that is skewed left, so here now my tail is on the left. Now this is skewed left data. And my mean is going to get smaller. My mean decreases. And once again, just like with skewed right data, the tail pulls that mean closer to it. So the mean moves to the left, the mean decreases, and then therefore is smaller than the median. Now, the good news is, whether we're looking at histograms, dot plots, or box plots, this idea that I have written down here, that is always going to be true. Symmetric data, the mean will be the same or close to the median. Skewed right data, the mean will be bigger than the median. And skewed left data, the mean will be smaller than the median. But what does this type of data look like in a dot plot and in a box plot? So what I want you to do is I want you to pause the video and I want you to see if you can provide an example of a dot plot that is skewed left, skewed right, and one that's symmetric. So here are the three that I came up with. The one on the left, I always like to kind of draw out that curve that's going to demonstrate it. You can see here, my tail is on the left here. So this one is skewed left. Here, you can see that if I kind of draw out that curve, that one is going to be skewed to the right. My tail is on the right. And then here we have, this one is pretty symmetrical. So again, see if you can remember, skewed left is the mean bigger or smaller. The mean gets pushed smaller, so the mean is smaller than the median. Skewed right data, is the mean going to be bigger or smaller or the same as the median? The mean gets pulled with that tail, so therefore the mean is going to be bigger than the median. And then symmetrical, they'll be about the same. Go ahead. I want you to see if you can provide an example of a box plot now that is skewed left, skewed right, and one that is symmetric. And then play the video once you're ready to see what I came up with. Here are my three examples. So once again, we're looking at the tail. Now, when we're looking at the tail, we're kind of talking about from that first quartile to the minimum, or from that third quartile to the maximum. So here you can see this longer tail to the left. This is going to be left skewed, or skewed left. So therefore, once again, the mean is going to be smaller than the median, or less than the median. Here you can see my longer tail now on the right here, so this is skewed to the right. And therefore my mean is going to be bigger than my median. And then finally, notice how this one looks pretty evenly distributed from both sides. This would be symmetric. And in this case, my mean is approximately or pretty close to my median. So here you have a picture or a couple pictures with some skewed data, a little bit of a summary of symmetric data, things that I've been talking about in the video so far. So if you want to take a moment, write this down, maybe include some of these pictures. You can see here we have our median. If we look at our right skewed, we have our median right here. And like I said, the tail pulls the mean, so you can see the mean got bigger. And then when we have left skewed, my tail is on the left, the tail pulls the mean, so you can see from my median, the mean got pulled to the left. And so my mean got smaller. So just another way to represent what we've been talking about so far in these other slides. On this last slide here, I did want to just show you once again the note sheet that I wrote down for myself, that if you want to write some of these things down, these are kind of the highlights. It shows symmetric distributions, and then it shows skewed right and skewed left data, so you can see the comparisons between the different data displays that we have learned so far this chapter. So go ahead, write this down, and I'll have this posted on Schoology later this week.